So I think the recording has started. So okay, so we will now go into the session. So I hope you are able to see the screen. So, so I welcome you to the seventh live session of the Engineering Graphics and Design course. So this is conducted by NPTEL. So again introducing myself, I am Vikram Balaji. I am a research scholar from the Department of Mechanical Engineering in IIT Madras. The course instructors for this course, as you might know, is Professor Dr. Sunil Kale and Professor Dr. Naresh Datla from IIT Delhi. So in previous session, what did we learn? So we saw about mainly the isometric projection. In isometric projection, we saw what is called as foreshortening, which means that since the outline edges of the object is not orthogonal or parallel to the projection plane, because of that there is some foreshortening which occurs, which means that the length which is projected upon the plane is reduced compared to the true length. So how we saw how much foreshortening occurs in isometric projection, then how to draw a simple isometric drawing from coded plan for simple objects. Then we saw how to draw isometric projection of simple polygons like a square, a rectangle, a triangle. Then we saw about hexagons, and then we saw about pentagon, then a circular object. So finally, after that, we saw one or two examples about isometric projection, how to draw the isometric projection from the given orthographic projections. So this is the things which we saw in the last session. So in this session, as you might already know, we are going to deal about something which is known as the working drawings. One will just highlight the laser. Okay. So what is working drawing means? So whatever drawings which we have preferred, either it could be orthographic projection or the isometric projection, and we follow the certain standards for dimensioning, for lettering, so whatever it may be. So after we produce the drawing, so we have to send it to the fabricator to be able to manufacture the drawing. So for that we have to produce what is called as production or working drawings. So they are a set of specialized engineering drawings that provides the information required to make the part or the assembly of the final design. They need to be sent to the fabricator to make the parts or the device. So in this diagram you can see there is a part is there which there is a part is there which consists of many other parts. They are assembled together in order to make the final product. So you can see there are two parts over here which they are numbered as number 1 and number 2, and then they are connected together by these bolts which you can see here, which is number 4, and then we have something called as a shaft which is running through the hole which is provided. So it could be a shaft or it could be a pin also. So what we know is that we have a part which is made up of many other parts. They are assembled together. So we have to produce what is called as a working drawing. So what are the requirements of the working drawing means? So we have to completely describe the parts, both visually and dimensionally. So whatever the parts there are there, we have to completely describe them. For example, this pin which is this bolt is which is provided there is here described here as number 4. The number 3, the pin which is provided, so that is described through the its front view and top view in the number 3. The number 2 and number 1 are the part orthographic projection of the parts. So we can see that we have 4 parts, and complete description of all the both 4 parts are given, and these parts are shown in assembly. So here you can see how the parts are going to be assembled. So that is what is being shown here. Third is to identify all the parts. So we have to identify. So this is number 4, this is number 2, this is number 1, this is number 3, like that, and to specify the standard parts. So this bolt is a standard part, so which could be there. Then so usually the standard parts will be the bolts, nuts, the fasteners basically. So working drawings show each part or structure in all of the views necessary to fully define their feature, their size, tolerance, and the way they are to be assembled to the complete product. So this is the introduction. So when we have a typical design, so for example we have made a sketch. We saw in the first session about visualization. So after visualizing an object in mind, we are able to make a sketch. rough sketch. After making the sketch, either we go for the drawing, or in nowadays we go for the solid modeling in some computer software, CAD software. So after that we have to produce what is called as the formal working drawing. So we have to indicate that part, we have to show the different orthographic views, or sometimes we can show the isometric view also. We should indicate all the dimensions of the parts, and then we have to indicate what is called as what is the material and what is the hardness here. So this is the title block. So in title block we have the we have the information about what angle of projection is being used. So what is the units. So if scale is none, means it is a 1:1 drawing. So this part number is there, and who has drawn the part, how it is, who has checked it, who has approved it. So all those details. So this is the typical design progression in any organization, and if there is any revision that has been done on this part, it will be indicated in another table, which is given here in the top. And some notes are also there, which are the notes which we need to convey to the fabricator in order for him to be able to manufacture this product. So there are some detail about the chamfer, there are detail about the cut, and each part to be backed into it. So these are the typical notes. So this is a part, and this is a example of a formal working drawing. So what are the components of a working drawing, if you ask me? So it consists of the following components. So generally we have assembly and sub-assembly drawings. So an assembly drawing shows how each part of the design is put together and how all of the pieces look and fit when this is done. The main assembly is then composed of smaller individual parts that can be either made especially for the device, or they could be purchased as commercially available parts. So here it means that we have different parts, how the different parts are put together and how they look when they are put together, that is conveyed in the assembly drawing. So what happens is, sometimes the assembly itself could comprise of many sub-assemblies, so as indicated here. So sub-assemblies could be some collection of parts which are either custom made or which are commercially available. So those parts are put together to create this sub-assembly, and this sub-assembly is then there could be many sub-assemblies which are then assembled together to make up the main assembly. So each sub-assembly needs its own layout drawing and the assembly drawing. So after the assembly or sub-assembly, we have something which is called as detailed part drawing. So detailed drawing is dimension multi-view drawing of a single part. So we saw that many parts are assembled together to create the assembly drawing. So each part we need the description. So what is the, suppose we have in the previous example we saw some bolts are there, as two parts are then fixed together, and then there is a pin which is going inside. So for each part except the standard parts, which means that there is a bolts and nuts, that we know the standard drawings are already available, so we did not again mention those things. But those parts which are custom made for this particular assembly, so they have to be described in this detailed part drawing. So they have to give the parts geometry, dimension, tolerance, material, finish, those details we need to be given. Next is bill of materials. So we saw the bill of material is basically the parts list. So what are all the parts? So both the standard parts and the custom made parts which need to be listed. So it is a complete list of the items constituting an assembly or a sub-assembly of detailed parts, which is presented on a technical drawing. So such item list provide necessary information for the production. So if we see the bill of material, the fabricator will be able to see, after seeing the materials, the parts and the materials, he will be able to roughly estimate what will be the cost for the production of this part. So for bill of materials is important. So title block. So title block gives the record all the important necessary information for the working drawings. So what is the scale followed, what is the units which are being followed, what is the angle of projection which is followed, who prepared the drawing, who verified it, all those details, and even some other details. So these all constitute a working drawing. So if you see as a hierarchy, we can see that there is a main assembly drawing is there, and then there are many part drawings and there are sub-assembly drawings. So one sub-assembly could be made of multiple parts, and one sub-assembly could be made of another sub-assembly, and that sub-assembly in turn could be made of many parts and sub-assemblies, and finally we see that we have many parts are there, many sub-assemblies are there, all they are combined together to give us the main assembly. So a set of drawings for a project is organized like a roots of a tree. So individual part fit into the sub-assemblies or the main assembly. So either it could be a part or it could be a sub-assembly, they all fit together to give the main assembly. So as highlighted here, we see that there are three main types of assembly drawings are there. So outline assembly drawing, exploded assembly drawing, and the sectioned assembly drawing. So these three we will be seeing each one by one. So this already will have been covered in lecture. So still we will just revise what are those. Okay, so outline assembly drawing is called as layout drawing. So they are used to show the fit and the function of all the various pieces that go into a complete assembly or a sub-assembly. So here we have the example of machine-wise assembly. So the third angle projection is shown here, and it follows the SI units. So this is a A3 sheet, and which is the company name, so part name and all is there. So other than that, we can see we have a multi-view of assembly, and there is a pictorial view also which is provided for the sake of clarity. So this is a machine wise, which means that there is this turner. So when you turn it, this block which is this holder which is here, it moves inside. So this basically it is used for holding a workpiece when there is some kind of machining operation, or it is just for a holding purpose. So when the workpiece is placed inside, we need to tighten this turner, and the holder moves towards this base, and we are able to fix the workpiece. So this is one kind of device is there. So this device consists of multiple parts. So these multiple parts are indicated by these different balloons are there. So number 1, number 2, number 3, like that. Likewise, there will be multiple parts. So an outline assembly drawing shows the final product in its final configuration using the multi-view format. So this is the final assembly. So that I am showing in the form of an outline. So in outline drawing, what we do is that the dimensions are not shown. Preferably they are not shown. That information we can see in the detailed drawing. So when we are going to see the detailed drawing of each part, so that time we are going to see what are the dimensions of each part. So when they are assembled together, we can using the dimension which are in the part drawing, we can be able to estimate the dimensions of this assembly. So but for the sake of convenience, we can say that reference dimensions like overall width, overall height, etc. And assembly dimensions are there. So where this part must be placed relative to another part, those can be shown if required. So those are basically for the convenience of the reader, who is the fabricator. So the parts or the sub-assemblies in the assembly are identified by ballooning. So ballooning is nothing but a circle that contains a number referring to the part, which is drawn along with the leader line pointing to the part. So this 10 indicates a part number, and then we are drawing a leader line towards the part. So this is the outline assembly drawing. So next type is the exploded. So exploded is nothing but, here we are using the pictorial view. It could be isometric or some other pictorial view also. Here what we are going to do is, they show how the various parts and the piece that compose an assembly or sub-assembly are put together. So for example, we have this machine wise. So this machine wise is then the different parts are then shown slightly away from their position. So when we are going to disassemble this assembly, so then that is called as the exploded view. So for example, this rod goes into this hole. So this holder is now fixed to this base. So that is shown here, and then this fastener, the bolt is used, and then this is another rod which goes through this hole. So like that we can see how many different types of parts and how they are fixed together and where they are going to sit in the assembly. So here you can see the bill of materials are there. So the base is made of steel, the lead screws are also steel, movable jaw is there. So there is a fixed jaw plate, movable jaw plate. So this left side is a fixed jaw plate, and the right side will be the movable jaw plate, because that is we are going to move by this screw mechanism. Then we have guide plate, then we have cap screw. So like that we have a lot of parts are there. So this is the lead screw. So the various parts are shown in their final resting orientation. So the orientation is okay, but the final location is not. So they are shown slightly away from their final location. For example, this number 4, which is the fixed droplet, is going to be fixed to this base, but it is shown slightly away. So we draw some dotted lines are there, which shows for how much distance it has moved away from the assemble location. So that you can see. So this screw, this movable jaw will be fixed to this jaw plate. This jaw plate, then this you have to fasten together by using this screw. So again, these dotted lines are shown where the screw is going to fasten and how this jaw plate is going to fix to this jaw is going to fix to the jaw plate. And see, and similarly for the bottom and how the lead screw. So everything is shown here. So this is a exploded assembly drawing. So again, as with the layout drawing, so the balloons are used for numbering, and the leader lines as usual point to the part. So this is the second type. The third type is the sectioned assembly drawing. So what we are going to do is the sectioning. We already seen in the last few sessions, last to last sessions, what is sectioning. So we saw the sectioning of solids. So similarly, there is the sectioning of the assembly. So the sectioning shows a graphic description of the interior. So the cutting plane is passed through the assembly. So wherever it cuts the part, so the material we are highlighting using this section lines, and different parts are there. So for that case, we need to show slightly differently. For example, some rules are there. So standard parts like fasteners, like screws, nuts, bolts, pins, gears, and some non-standard parts like shaft. So shaft, when you are when the cutting plane is passing through the axis of the shaft, so that time we are not going to section the shaft. Whereas when it passes perpendicular, so which when it shows the cross section, so when the cutting plane passes to the cross section of the shaft, that time we are going to see. So for example, let me take this pen here. So I am going to draw some cylindrical shaft is there. So let us say this is like a long shaft. So I am showing this end, so that it is a long shaft. So we don't know the length, it could be long. So and this is the axis. So when you are going to cut the plane like this, so when the cutting plane is going to be like this, so in the side view you will be able to see that. So your cutting plane will come like this. So for example, you are seeing like this, or you can see like this also. So whatever is the direction. So for example, let me say that I am looking the other side. So I am going to look like this. So let us say I am following the third angle projection. This is my right side view, and in the right side view I am telling I am going to look at the part. So this is the part which I am going to look over here. So here, suppose this is my AA. So this time when you are going to draw this, I am not going to section this, because my cutting plane passes exactly through the middle axis of the shaft. Okay, so there is another possibility. So for example, when the cross section is like this, for example, this is my shaft. So I'm drawing, and now I'm going to cut like this, and I'm going to view this. So let us call this BB. So in the side view, if I am going to do, I am going to section this. So any doubt in there? So when we are going to section the shaft and when we are to avoid the sectioning of the shaft. So this is the rule. For example, if the cutting plane passes through the axis and it is parallel to the shaft, then we are not going to section it. So in the sense, if I am going to erase this plane, so I am going to draw the sectional front view means I am going to draw it as it is like this only. So I am not going to shade over here. So that is the thing. And here when the cutting plane passes perpendicular to the axis and it is parallel to the cross section, then for highlighting the cross section we are going to section it. So any doubt in this thing? So I hope there is no doubt. So that is for the shaft. So they are done showing their exterior features. So whatever the fasteners are there, they are done showing the exterior features. The bearing may not be sectioned if the drawing is too crowded. So that we may see when we are discussing about bearings. So in this we are going to only discuss about simple assembly drawings. So we may not go much into bearings. So adjacent parts in the section are lined at different angles. So for example, here when I am sectioning two parts together, so I am sectioning this part as well as I am sectioning this part means, so they should not be two parts which are in contact, they should not have the same sectioning angle, because that will create a confusion. So to show that this material is different from this material, so these two are different objects, so I am sectioning this maybe in plus 45, then I am going for minus 45, then maybe again I am going for some other angle, so I can go for plus 30 minus 30, so plus 60 minus 60, so something like that. So thin parts like gaskets are shown solid black. So thin parts like sheet metal, for example, they may be only 1 mm or 2 mm thickness. So when you are going to section them, so it will give an impression, it will give some confusion. So this is actually much thicker, but in some cases we have even less than some around 1 mm we are going to draw means. So that time we are not avoiding this, we are avoiding the sectioning and we are going to shown as a solid black. So like this, for example. So there is some gasket which you can see in the pressure cooker and all. So those gaskets should be very thin depending on the application. So some applications have very thin gasket means we are going to hatch it by coloring it. So we are going to show it as a full solid black color. So we are not going to section it. So this is one another convention when we are going to follow the sectioned assembly drawings. So these are the different rules. Okay, we will see one small example. So we have a key joint over here. So keys are basically machine elements which are used to prevent the relative rotational movement between a shaft and the parts mounted on it, such as a pulley, gear wheel, coupling, etc. So in this case we can see that, so this red color part I am saying it is a pulley. So this grey color part is shaft, and this black color part is the key. So why we are inserting this? Any idea? So can anybody guess why we are inserting this key? What is the main reason? Is it just for fixing? So can anybody guess why we are inserting keys? If it is just for fixing, or is some other reason is also there? So what is the reason is that when the shaft is nothing but this is a rotating device. So when we are transmitting some power to the shaft, so what happens that this rotates. So same, the pulley also needs to rotate. So in order to avoid any relative rotation, so if the key is not there and if we are just rotating the shaft, there is no depending on the friction value, we can say that the pulley may rotate or may not rotate. But when we are now inserting a key, we know that this pulley is also going to rotate along with the shaft. So by this means we are transmitting the torque from the shaft to the pulley also. So this could be here I have shown pulley, but it can be anything like a gear, it could be gears, it could be wheel coupling, etc. So sometimes when you have another pulley over here or another gear over here, and you have some shaft associated with it, so like this. So when this shaft rotates, this gear will rotate, and this in turn will induce the rotation in this gear. So because of the rotation of this gear, that gear will be keyed to the shaft, and the shaft will also rotate. So this is like a transmission of power from one parallel shaft to another. So this is one other example. So this is one of the main application of key joints. So however, one disadvantage of key joint is it is only suitable for light loads. For heavy loads we need much more stronger couplings, like for example in cars we use clutches, and we may use other flange couplings, those and all. So this is suitable only for the light loads. So how we are seating is that for making the joint, so the groove is provided. So here is the keyway. So this keyway is provided, and it is not only provided on the top surface of the shaft, it is also provided on the this part. So can anybody name what is this part? So here I have already shown. So it is the hub. So this hub is the protruding part, and this part is nothing but the flange, we can say. If there are bolt holes are there, so usually flange we can say, and this part is the hub. So the hub also contains a negative. So if this is a positive, this could be opposite direction, it's a negative. So like that is there. So when these two are now, when the shaft is then inserted into this pulley, and then the positioning is such that both the keyways should be properly aligned. So after aligning the both properly, so then after aligning them properly, the key is then driven inside. So after the key is driven inside and is seated inside, we can say that now the key joint has been made. So this is one example. Here we can see here, these are the part drawing is there. So this is the key, it has some width, it has a length, and it has some thickness, and the top portion is given some taper. So taper is nothing but, when you see in the front view, so this will be a shorter length, this will be a longer length, and you can see this line will be a slope line. So usually this slope is very low, it is not as indicated here. The slope will be something like 1:100 or there, or 1:30. So those kind of slopes. So for every 30 mm, you can say that there is a 1 mm increase in the vertical length. So that is the thing. So this is a taper, and this is the key, and this shaft is shown with the keyway. It has a particular diameter, and similarly we have the drawing of this pulley. So this pulley has an inner diameter and the outer diameter of the hub. The inner diameter is given a keyway, and this is the flange part. So as when they are assembled here, so this is showing the sectional front view means. So you can see that we are sectioning only the hub and the flange portion, whereas the shaft you are not sectioning, if you can see closely, because so this is a half sectional view, we can say. The shaft you are not sectioning because, as I last indicated in the last, so here the cutting plane is parallel to the axis, and it is passing through the axis and parallel to the shaft. So here we are not sectioning the shaft. And key, as I told, so like pins, gears, fasteners, any fastening thing is also not sectioned. So that is also not sectioned. The shaft and the key are not sectioned, only the pulley is sectioned. But if you see in the side view, if you are going to doing the sectional side view, for example I am cutting like this, so that time you can see that I am sectioning the shaft also. So that is one example. So shaft, as I showed. So this is an example of a key joint. So now we are going to see a sample question. So we have one what is called as a knuckle joint. So similar to key joint, knuckle joint is also a joint which is now used to connect two rods. So this is two rods will be there. One is the fork end, you can say, another is the eye end. So fork end and eye end, we have these two rods, and we have the fastener. This fastener is nothing but a pin. So how this pin is is this going through these two rods? So how it is going means, for example, so this is shows the how they are going to fasten. So this could be the exploded view. So this is my, as you can see, if we go back, so this is the fork end. Okay, this is the fork end, and this is the eye end. So this is going to be the fork. This is going to be the eye end. So we can see that this is a shaft is there, here also one shaft is there. So I am now connecting these two. You can say this is a rod. Maybe this is not a rotating device, so it is a rod. So when you are going to see two rods which are connected together, for example, if you can see in wrestling matches, so you can see that in the ring side there will be four this thing ropes will be there, and those ropes are connected to each other by a turnbuckle. So that is one kind of a joint. So the turnbuckle helps to connect one rod to another. So here we are connecting it parallelly both, or else we could connect something in incline also, or perpendicularly also. So one rod goes like this, another rod goes like this. So we are going to couple them both. How we are going to do that means, this pin will go inside, and this pin will then be, the collar will be inserted from the below, and a pin will be another smaller pin will be inserted through this collar that passes through this pin, and then the arrangement will be seated. So for the convenience purpose, I made a illustration in the AutoCAD, so I can show you now. So this is my fork end. So this part will be my fork. So this red will be my eye. So this will be the pin. So the pin, as you can see, it is this part. So it is entirely passing through the both the fork and the eye, and this is the collar. So and I am going to take this, so you can see this pin and this collar is here, and how they are going to sit is because of this smaller pin. So you can see some kind of a taper is also given. So when you observe this, so when you are able to see, you can see there's a small slope kind of thing is there. So that is a tapered pin. So this pin is going to sit through this hole provided. So this system is now firmly arranged. So what now, so I will say this is the pin, this is a collar. So this is a pin, this is the collar, and this is the taper pin. Okay, so these are the things. So we can see for each part they have given one, for the fork end there is a front view and top view is given. Similarly for the eye end we have the front view and the top view. This is the only single view is provided for the pin, and similarly for collar we have a single pin. Here there is a sectioning is provided so that to indicate it is a hollow, inside a hollow, and there is it's a kind of a shell. So if I go to AutoCAD once again, if I just, let me say I am moving this just to show this part. So now you can see that it is a ring kind of a thing which is hollow inside, and only the material is present in the outer, and there is a hole which passes through it. So you can say that this sectioning is done to indicate that, and this is a taper pin, you can say. So it is 7 mm in the upper side and 5 mm in the lower side. and it is a 45 mm in length. So this taper pin will now go through both this collar and the pin. So this pin will go through this hole which is here. So this will so you can see, so this fork end, it is going to have two handles are there, and here the eye end is going to have a single, it will go inside, over here. After this goes inside, this pin goes down, it travels till this bottom of this top this thing protrusion touches this surface, and then again from the bottom this collar goes and sits here, and when the holes of the pin and the collar are aligned, then we insert the taper pin. So what they are asking is, the parts are given, we have to draw the sectional front view and top view of the assembly. So these are the parts are there. So for the purpose of visualization, I have already if you go back to this AutoCAD, so if I say this is my front, I have already sectioned this thing. So you can see that this is the pin which is sectioned, this is the fork end which is sectioned, and this red color is the eye end which is sectioned, this orange color is the collar, and the blue color is the pin. So that only I have indicated in this thing. Okay, so if I am going to start the section, let us say I am going to draw this baseline. Sorry, let me erase this. So I am drawing only in freehand for this thing, since I am doing in computer. So when you are going to draw, so you have to draw as per the perfectly in the given dimensions and all. You have to draw it in the sheet of paper. So like this I am going to draw, sorry, first I draw correctly. I am going to draw the center line. So for the purpose of convenience, I am going to represent here also. Okay, so this is, as I told, this is a rod which is shown here. There is some feature is there, so that feature only they have indicated like this. It is kind of a octagon. So you can see that I am having a octagon shape is there. If I go back to the AutoCAD, so when I go to the main drawing, so this is sectioned, so the other half of the section is here. Yes, so if I see this part, so this part is nothing but after the fork is finished, so it is finishing at a square section, but after the square section I am having some octagon profile is there. After that octagon profile only I am having the shaft. So that is what is indicated by these diagrams also. So this is the fork, so this is a 30 square is there, some up to this portion you can say that it is a square. So there is some 30 mm of octagon is there. So this is 30, this total is 100. So for after some square portion there is a octagon portion. So that is what I indicated. After this octagon portion we are having the shaft portion. You can say it is shaft, or you can say it's a rod also, no problem. So when I am going to section, so okay, so this is the fork, so this is the octagon portion, and this is the shaft portion. So when I am going to section this fork, I am going to section like this. So this is the material I am indicating for fork. So here when we come up to maybe what we are going to do is we are going to section up to this part. We are going to draw some kind of a break line up to this part. So why we are not sectioning this octagon and shaft is, a shaft, as I already told you, it is this section plane is passing exactly through the center of the shaft, so this shaft part we are not showing. So when I am going to draw, so let us say I am drawing like this. Same thing here also. This is some radius will be there, and this will have some fillet radius, and it will go like this up to square here. So then we will have the octagon portion. So how that octagon portion is represented is, so like this. So like this here. So this is how it is represented. So we are going to section only up to this. So why we are not sectioning this part is, so as I told, this is shaft. So here it is exactly passing through the central. So we are avoiding the sectioning of the shaft. But this portion is to indicate the octagon feature. Otherwise, if you are directly going to just as a section, it is not going to make any difference. So for example, if I am going to section this also, finally what I will be having is, I will having this kind of fork. So something like this, and here there will be shaft. So I will not know whether I am having this octagonal profile itself. So if entire going to section means, so I will think that there is no octagon profile is there, some square profile is only there, I will be thinking when I going to see this section. So in order to differentiate that, that's why we section only up to some portion. So like this. So like this we are sectioning. So only up to some portion we are sectioning. Only the fork part and the square part we are sectioning. The octagon profile and the shaft we are not sectioning. So I hope there is no doubt. I hope it is clear why we are doing like that. So like this it becomes. So like this it becomes. So we have finished the fork, and similarly for the eye end also we are going to fix. For example, so this line is there, so maybe it will sit somewhere here. Again this line will be there, so corresponding to this line. So if I am going to section, so here also I am going to section only up to the square portion. So I will use some minus 45. So like this I am going to section. It's come to full line. So like this I am going to section. Up to the square portion. So let me say that it is this kind of section. So if I show is minus plus 45 means the other material, the eye end is minus 45. So here I am going to show the octagonal profile. So something like this after filleting those things. So this portion, so it can be represented. This is only for the representation purpose, and then we have the shaft. So like I said earlier, the shaft and the octagon we are not sectioning. So like this. So next we are having this pin. So it comes like this and sits like this. So can anybody say whether are we going to section or we are not going to section this part? So can anybody answer whether I am going to section or not going to section? Okay, somebody has messaged. No. Okay, that is correct. So we are not going to section this part. So as I told, any fastener like this. So as I showed here, these fasteners like dowels, pins and gears and pads, shafts, when they are sectioned, when they are not sectioned, I just explained. So here also it is not only when the cross section is cut we are going to section it, otherwise we are going to show as it is. So this we are going to show as it is, so it is not section. Silver, yes, Silver Raju, please. So can you can ask your question, Selvaraj sir, or if you are not able to ask, you can message. Okay, so this is 3 parts we have looked. 4th part is this collar. So this collar will come like this. So here are we going to section or not going to section? Let me add this center line. So here, yes, we are going to section. So collar, see it is plus 45, you can either go for this minus 45 or some other angle like minus 30, something like this you can. So last part is this taper pin. So this will come inside. Okay. Yes, not sections. Okay. Yes, correct. So are you saying for this this pin, or are you saying for this taper pin or this long pin? So if it is the long pin, yes, we are not sectioning. So next question arises whether the small blue color, are we going to section or not? So it is also a pin only. So are we going to section or no? So we have to see the orientation. So whether it is cutting the cross section or whether it is cutting the axis for this. So it is cutting along the cross section, it is not cutting the axis. So we are going to show. So is it correct or we should not show for this pin? So can anybody say whether we are going to section or not going to section? So you can message it. The small part, is it whether the same shaft which I showed you, whether the same applicable to pin also, or not? Pin is a different convention. So we saw that for the pin, when it passes through this thing, we are not sectioning. So but here it is cutting the cross section. So whether we have to follow what is followed for the shaft, or or should we avoid the sectioning? So that is the question. So can anybody answer that? Okay. So I think we should not section. That is what I am thinking. So whether this is wrong or correct, can if you can point out? Yes, yes, not section. Correct. So for the pin purpose, we are not going to section even if it cuts the cross section. For the shaft, if it was the shaft, then we are going to section. But since it is a pin, it is a fastener. So for fasteners in any sectioning, we are not going to show whether it's a nut or bolt or a pin. At any sectioning point, we are not going to show. So we are going to show this feature as a pin normal feature only without sectioning. So that is the thing. So this is the sectional front view as far as concerned. For top view, similarly you can generate, like for example, you can refer to this thing. If you see the top, so you can see what so this was the section, this is the cut. So you can go to this and see. So you will be able to see this one, this circle will be there. Similarly, this circle will be there. So top view you can able to draw. So if I draw maybe here, so since you have drawn the sectional front view, top view is nothing, you just you are able to see what are the different things. So you have to just combine. So this and this you can combine, and sometimes if it is necessary you can show the hidden lines, otherwise it is not necessary to show. Only the pin, I think it will be hidden, that we have to show in the thing. So for example, so if I again go to AutoCAD means, so from the top you can see, you are able to see this shaft, and you are able to see this octagonal feature, this square feature, this fork, and this pin, this long pin, then again this octagonal feature, this square feature, this shaft you are able to see. But the collar and the pin we are not able to see, but they are, since they are located below. So for the collar and pin we are going to show on the hidden line. So that is the top view. So since I'm only more concerned about the sectional front view thing, the top view you can I hope you will be able to manage. So anyway, we can try to do a small quick freehand sketch. So as I told, you will be able to see this shaft over here, then this you will be able to see this octagon feature for the eye end, I am telling. And then you will be able to see then you will it will be overlap with the fork. So this circle, you can say, the both will overlap. So here one more inner circle will be there. Then again you can see that here there will be this feature. So you can again go to AutoCAD and check. So from top, if you are going to select top view, okay, so this should come like this. So I drew opposite. So it should be this way. So like this you will get. Here you can again repeat this square part, this octagon part, and the shaft part. So like this. So sorry, this line won't come. So like this. So just for the square part I drew the line, but the line will not come in real time. And then to draw the shaft. So here also this line won't come. So this will thus simply overlap. This again, I think there's a mistake. So yes, so like this. Okay. So this part and this part we have done, and again there will be this another circle due to, sorry, this will be hidden actually. So again, if you go to the add and see, only two circles you are able to see. One is the outer circle of the eye rod, sorry, fork rod, and another is the this one, long pin. So that will be much more closer. Inside you have a hidden line. So similarly for this collar also we will have some line. So here we have to see whether both are, so this is 40 and similarly this is also 40. So that 40 and this 40 will overlap with each other, so we don't need to draw. Only thing is this, you have to draw the pin, so that whether if you see the AutoCAD how long that pin is coming, whether you are able to see the pin from the top. No, we are not able to see fully. So it will be contained entirely inside this length. So suppose we are drawing like this. So it will start from here and it will end from here. So the pin will run cross like this. So it is a hidden, and it is contained entirely inside. So it will cross the collar, but it will not cross the fork, that fork circle. So like this we can draw. So I think then you can this shaft again I will close it. So I think this much is there. So I don't think there is anything else left. Is there anything? So I have shown the pin, taper pin. I have shown the collar. I have shown the inside circle. I have shown the outer circle for both, and both will overlap with each other. Then the octagon profile and the shaft. So I think this is the top view. And if you want to show the section, I think it will come like this. So we are going to see the front portion. So when we are sectioning like this, whatever is visible to us, that we are going to section. So this is for knuckle joint. Similarly, one more example I show here. So we can quickly just go through this. So this is a valve assembly. So different pictorial views are shown here. The assembly of a valve is shown, and the part drawings are shown in the adjoining figures. So draw the top view and the sectional front view. So so these are the part. So this is the lug. So this is that lug part is there. So this is number 1. So here you can see number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, number 10, number 11. So first is the main part of this assembly. So that is the valve body. Number 2 will be some pin which is crossing through. Number 3 will be this thing. So this is I think some kind of actuator. So number 4 is this bottom one plate is there. And then we have number 5. So there's a base plate in the inside. Number 5 is the bottom below this valve body. Another plate we are attaching. Number 6 is this is the I think fluid passes through this I think, and then it is some valve. So based on this thing, so this will whether how much this pin is located. So this location of this pin, if the pin is partially located inside, it will regulate some valve. So if it is fully done means the valve will be much more regulated. So like that, I think this is the thing. So this will go in and out, I think. So that is the 6 is the this is the part which connects the valve body to this actuator. So number 7 is this below there is a nut. Number 8 is a number 7 is the bolt. Number 8 is a nut. Number 9, it is some hole which is provided in the regulator. Number 10 is again this thing, a bolt, and 11 is a square nut. Okay, these both are nuts actually. This entire thing which passes through. So this entire pin passes through this, and it is fixed by 2 nuts. So one is this square nut and another is hex nut. So like this we have 11 parts. So each part they have shown the drawing. This is the inner regulator pin. This is the valve body. This is that actuator. And this is number 4 is the base plate. Number 5 is the bottom valve body, bottom part of valve body. Number 6 is the thing which connects the actuator with the valve body. Number 7 is a hex bolt. Number 8 is a hex nut. Number 9 is a pin. Number 10 is again a hex nut. Number 11 is a square nut. So all we are showing. So again we can go to AutoCAD. I have modeled this thing. So when we are modeling it, we are able, but when it comes to real time, you need to be able to visualize. So this is the thing. So here you can see, this is the valve body is there, and that is number, I think that is number 1. So let us now go one by one. So number 1 is this valve body. We'll go to this pictorial view. So that is there. Number 2 is that regulator pin. So that is shown in the yellow color. It passes through in the hole which is located. So we have located number 2. Number 3 is this actuator. So that is this blue color. This is number 3. That also we have located. Number 4 is this base plate. So this base plate you have to see properly. So inside there will be some black color plate will be there. If you go, so maybe from the bottom you can be able to see. Yes, see. Yes. So here is a bottom base plate is there. That is black color. So that also we are able to see. Number 5. This below the lug, below the valve body, this magenta color I have shown. So from top also I think we are able to see. Yes, this is the black. So that is our number 4. Number 5 is this magenta. This is number 5. Number 6. This PCD circle thing is there. So that is, I think, this one. So this I have modeled for the sake of convenience. So this plate. Yes. So this blue color actuator we saw, which is number 3, that and valve body are now connected by this thing. So we saw that one yellow color pin is running. So that pin runs entirely throughout the body. So like this. So if you see that number 2, so it is like this. So here it will be attached to the base plate. So here one base plate will be provided, and that will also have the corresponding holes, and one pin will sit like this. So if you see this number 4, that is exactly this base plate. So here they have shown like it is inclined upward. In reality it will be inclined opposite. The base plate will be given and the pin will be like that. So number 3, number 4, number 5 also we saw, number 6 also we saw. Number 7 is a hex bolt. So which one is that? So this one. Yes. this green color part which is running throughout. So here the head of the hex bolt, and this is the rod that hex bolt this thing run. So it is going like that. Number 8 is the hex nut. So this is that cyan color. So this is the hex nut. So we can see there are 3 like that. There are 3 hex bolts. There are 3 hex nuts corresponding to the 3 holes in the valve body. So this extrusion, this protrusion part is called as the lug. So this lug, we are connecting the valve body and the bottom plate through this lug. So we have 3 holes. There the hex bolt and hex nut are connected. So that is number 7 and number 8 we have located. Number 9 is this small pin. So I hope you will be able to see. This brown color thing is there, right? So I hope they are visible. So this is the pin. So in section view you will be able to see better. Here you will see number 9 as n. Number 10 and number 11, all the these 2 nuts are there. So that which connects the rod, that inner pin through this. This is the hex nut and this is the square nut. So we have located all the 11. So for the sectional front view, I have drawn a plane like this, which is exactly cuts this 2 in half, and so now we are able to see. So yes, so I showed you the pin, right? So that brown color. Now we are able to see that pin. So that half body is there. So this is also similarly the hex bolt half is running, and these are the valve body parts. This is the nut, this is square nut, hex nut. This is that actuator. This is that red color is that PCD circle. This is the valve body. This is the bottom base plate of the valve, and these are the, this is that yellow color is that pin. So which is run entirely through. Okay. So that picture I think as I have shown here. So when we are going to section it, so this green color, whether we are going to section it or not, it is a fastener. It is a hex bolt. So are we going to section or not? So can anybody answer? So if you are not able to, you can respond through the messaging also. Okay, so this is I think different. Okay, I will quickly go through this. This we are not going to section. So this valve body and this bottom plate we are going to section it. Similarly, this nut also we are not going to section. So here is empty material. Here again we are going to section. So like this. Here we are going to section opposite direction. So here since for the purpose of convenience I am able to visualize to 3D model, but when you are solving the assignment you need to be able to visualize mentally how it is going to look. So that will be slightly difficult, but with some practice you will be able to do. Okay, and this is that PCD circle. This I am going to section. So let us say I am going this some another angle. So here you are able to see that not any bolt circle. We actually that PCD circle has 3 bolt circles. So but this section plane none of them pass through. So you can see here this also has, so 3 bolt circle. So one is here, another is here, another is here, but the section plane passes through this one, so it is not cutting, so hence we are not able to locate it in this view, since it is a sectional front view or drawing. So like this, sometimes in order to do that we can go for another kind of view, so it may be another section plane only we can able to see. Similarly, this I am going to section, so this way I am going to section like this way. So this is the actuator. So these two, this is a hex nut and this is a square nut. So since they are fasteners, I am not going to section them, and since these both are pins, so pin I am not going to section at all. So I think this is the sectional front view, if you ask. So here the hex bolt we are not sectioning, the hex nut we are not sectioning, here also hex nut, and here also the square nut we are not sectioning. This actuator we are sectioning, this base plate, this base plate we are sectioning, the valve body we are sectioning, and we are sectioning the this another cross plate. So this is the valve assembly. Similarly, after combining everything, you can able to draw the top view also. So each part I have shown here, so you can combine them and get the top view also. So top view will be without sectioning. Okay, so with this we come to the end of this session. So we'll quickly see what we saw in this session. So I introduced the working drawings. So what are the, in the typical design progression, what is the working drawing is the end result. So that is the, so what are the different components, so what is an outline assembly drawing, what is an exploder assembly drawing, the section assembly drawing, these are the 3 parts. And we saw example of a key joint, this is a simple example, and then we saw one kind of another joint called knuckle joint. So this is slightly more complicated. We saw the sectional front view and top view, and this is valve assembly. This we saw there are 11 parts, so this is even more complicated. So we just with the help of the 3D model, we just cut, we saw the cut portion, and we are just identifying where we are going to section it. So this is a thing. So with this we come to the end of this session. So are there any doubts in what we discussed? So if there are no doubts, then I think we can close the session. So shall I stop the presentation? So if there are no more doubts, I think we can close the session. So are there any doubts in what we discussed? So we just saw some example. Okay, thank you. Okay, thanks. Okay. So I think we can close the session. I will stop the recording now.